Hey everyone, and welcome. Today, we're jumping into some seriously powerful stuff on the Linux command line. We're talking redirection, pipes, T, and Xargs. All right, let's get right into it. So what if your commands weren't just isolated little programs? What if they could actually talk to each other? Instead of running one command, seeing the output, and then typing another, what if you could just link them all together in one powerful chain?
Because that's the thing. Linux commands aren't meant to work alone. The real magic of the shell, the thing that makes it so powerful for automation and scripting, is making these commands communicate with each other.
The best way to picture this is like a digital assembly line, right? Each command you run is like a special machine on that line. One machine sorts things, the next one cuts them down to size, and a third one counts them up. Data flows from one to the next, and you're the one in control of that flow.
So before we can start redirecting all that data, we need to understand where it goes by default. In Linux, every single command has 3 default channels for communication. We call them the standard streams.
First up is standard output, or STDOU. You can think of this as the main conveyor belt. It's for all the normal successful results. When you run a command like ls and it works, that list of files is sent to STDOU, which is file descriptor number 1. And by default, it just shows up right there on your screen.
Then you have standard error, or STDER. This is a totally separate channel, file descriptor number 2, and it's just for problems. Error messages, warnings, permission denied, file not found, all that stuff. Now, it also goes to your screen by default, but the important thing to remember is that it's a completely different stream than stdout.
And finally, there's standard input, stdin, which is file descriptor 0. This is the stuff you're feeding into the command. By default, it's just your keyboard. When you type something into a program that's waiting for input, you're sending it data over stdin.
And here's a perfect example of why this separation matters. If you try to list a directory that doesn't exist, what happens? You don't get a result on stdout. There's nothing to list. Instead, you get an error message on stdr. This is so important because it lets us handle successes and failures in completely different ways.
Okay, so we know about these default streams. But what if we don't want the output on our screen? What if we want to save it? Well, that's where redirection comes in. We can reroute the flow.
The 2 big ones you'll use all the time are the greater than signs. A single greater than sign takes the standard output and dumps it into a file. But be careful, it will completely overwrite anything that's already in that file. The double greater than sign is usually a bit safer. It appends the output, adding it to the very end of the file without deleting what's already there.
And I really can't stress this enough. Using a single greater than sign on a file that already exists is a destructive move. The original data in that file will be gone. Poof. So just always double check that you really mean to overwrite it before you hit enter.
Now there are a few other handy operators to know about. The less than sign does the reverse. It takes the content of a file and feeds it into a command standard input. The 2 greater than is super useful. Remember file descriptor 2 for errors? This lets you capture only the error messages and save them to a log file. And finally, and greater than is a great shortcut for when you just want to capture everything, both stdout and stdr, and send it all to the same place.
Okay, let's get to the real powerhouse of the command line, the pipe. That's the vertical bar symbol. What it does is simple, but it's brilliant. It takes the standard output from the command on the left and uses it as the standard input for the command on the right. It's so efficient because the data never has to touch a temporary file on the disk. So let's say you're trying to find all the system accounts that can't log in. You run a grep command, and boom, you get a whole bunch of lines back. The information you want is in there, but it's raw, it's messy, it's kind of hard to read.
Exactly. You've got all this data, but it's not useful yet. It's just noise. So what do? How do you process this further without saving it to a file and running a bunch of other commands?
You build a pipeline. You take that messy grep output and you pipe it to the cut command to pull out just the usernames. Then you take that result and pipe it to sort to put them in alphabetical order. Just like that, in one single line, you've created a custom tool that gives you a clean, sorted list. That's the power of the pipe.
All right, now that you've got the fundamentals down, let's look at 2 more utilities that give you even more control over the flow of your data, T and Xargs. The T command is really easy to understand if you think about plumbing. It's like a T-joint in a pipe. It splits the flow of data.
So you pipe your output into T, and it sends one copy right to your screen so you can see what's happening, and at the same time, it sends another copy to a file for logging. It's awesome when you need to watch a process and save its output.
Next up is XArgs, and I just love this quote from the source material. It's true, saying it is half the fun. But seriously, it solves a really common and sometimes tricky problem.
So what does it actually do? Well, XArgs is basically a converter. It reads a bunch of lines from standard input, like a long list of file names, for example, and it cleverly turns them into command line arguments for some other command, like RM or CP. It's how you can act on a whole list of things at once.
Now, with all this power, you gotta be careful. There are a few common mistakes that can really trip you up. We already talked about accidentally wiping out a file with greater than instead of greater than greater. Another one is forgetting to put quotes around wildcards, which can give you some really weird results. But the most dangerous one is just blindly piping a list of files into XArgs RM.
And this slide right here shows the single most important safety tip for using XArgs. Before you run a command that could delete something, test it with echo first. Instead of actually running RM, XArgs will build the full command and echo will just print it to the screen. That way you can see exactly what's about to be deleted before you actually do it.
Okay, so let's wrap this up with the key takeaways. Redirection gives you total control over where your data comes from and where it goes. Pipes are the glue that lets you connect commands together to build those powerful workflows. T is your friend for when you need to see your output and save it at the same time. And XArgs is the tool that lets you build new commands on the fly from a stream of input.
You see, these aren't just separate little commands. They're like building blocks. And now that you know how they work, you can combine them to create your own custom tools to solve pretty much any problem you can think of. So go on. What are you going to build?